This is the second webinar of the Spring Tree campaign, and it will focus on the role of trees in cities, in the way how the trees help us to cool our cities, to fight with the urban heat island effect. The webinar will take about an hour, 1 hour, and you will hear about this topic from the point of view of scientists, and you will also see a short example from school, so more from practice. And I think that's the main information to start with. I don't know if anyone has any question or any technical problems before we start. Seems not. If yes, then please let us know in the chat. And so I would like to introduce our main speaker and our precious guest, Dr. Kevin Czajkowski, who is a scientist, professor at the University of Toledo in the United States. And he's also leading the Globe Urban Heat Island Effect campaign. And Mr. Czajkowski will talk to us about the urban heat island effect and about the role of trees. So Kevin, please, the floor is yours.
Well, thank you, Alenka. It's great seeing everyone, and it's great seeing people. I know a few of you, and I'd like to get to know the rest of you. So this is a great opportunity. So I'll get right into my presentation. And, all right, so, okay. There we go. I'm going to talk about the urban heat island effect and globe, and then trees. And just, this is a satellite image, and it shows red and yellow are warm, the blue is cold. Of course, these are the Great Lakes. And I did some presentations for some students in Europe recently and asked them which lakes are these? And some of the students knew. So we have Lake Erie, Lake Ontario, Lake Huron, and Lake Michigan. And of course, I grew up near Buffalo, New York, and that you can see the urban heat island for Buffalo. And I live over here in Toledo, and these are schools we've worked with, these little flags. Detroit has a big urban heat island, Cleveland, and then here's Toronto in Ontario, Canada, and they have an urban heat island as well. And we can see those from satellite. And just a little bit about myself, I got very much interested in meteorology when I was 10 years old. There was a blizzard in Buffalo in 1977. You can see the snow. School buses were lost, which was not the best. I was not on one of them. My school closed, so that was nice. Ahead of time, knowing that the storm was coming. But some schools stayed open and the buses couldn't find their way home. But all kids were safe. No one got hurt. None of the kids got hurt. Then I became a meteorologist. I went to a college called Oneonta. Okay, here we go. Back. Then I got my PhD at the University of Michigan, and now I'm at the University of Toledo as a professor. And a little bit about my family. I'm married to Kathleen, well, for 27 years. I have two sons. Robbie's in graduate school to do his PhD in machine learning. And then my youngest son, he plays football at college, so, you know, international football. And he's studying computer engineering. I love to make an ice rink in my backyard every year, an ice skate. And of course, where we live, it's cold enough that about two to 3 months a year, it's cold enough for an ice rink. And then here's our dog. And this project is part of Globe Mission Earth. It's a NASA-funded project, and we have collaborators across the United States. So this is mainly a US-focused project. Now, I'm sure people know the urban heat island. Downtown areas tend to be warmer than rural areas that have trees or agriculture. And you can see Fahrenheit on the left and Celsius on the right here. Yeah, partly it's due to less moisture in the city, more human materials absorb sunlight, warm up, and then retain that heat throughout the day. So here's an example of an image. The blue is cold, these are trees, and then the roofs of the buildings giving off heat. So buildings, you know, the heat from inside a building can also come out. and give off. And then on the left here, we see how asphalt, the sun heats the surface and the asphalt retains the heat. Grass, on the other hand, has a very high surface area to volume ratio. So when you heat up the grass volume, it's like your fingers. Your fingers get cold, right? Because if they're giving off heat, they don't have a lot of volume to them. And the grass is the same way. Here's an example that NASA did of Buffalo, the urban heat island. As I mentioned, I grew up near Buffalo and we had a big blizzard. That got me interested in the weather. Oh, one of the reasons it was so interesting is we got to miss school for 1 week. And I just love missing school and having snow days. So I studied meteorology and went to college for 10 years. So that's how that works. So urban heat island can cause an increase in energy consumption. It can increase greenhouse gas emissions and ozone, so ozone's a pollutant, and it can also increase deaths or impact people's health. Now, a little known fact is if my wife and I travel anywhere, that will be the hottest time that area's ever experienced. So when we went to Ireland for the Globe learning expedition a few years ago, there was a heat wave in Ireland. Before that, we had gone to Switzerland and Germany and France, and there was a big heat wave during that time. So anytime I go anywhere, there's a big heat wave. All right, so this shows energy use, electric use on the y-axis versus temperature on the x-axis, Fahrenheit on top, Celsius on the bottom. So when the temperature gets to about 25 Celsius, the electric use goes up quite a bit. Especially in the United States where we have air conditioning. Everybody turns the air conditioning on, they want to be cooler. Of course, that puts a drain on the electric grid and can cause electric outages. So we have the Urban Heat Island campaign. It's actually been converted by Globe to an intensive field observation period. It doesn't mean much to me. I mean, it's a different word, but it's the same thing we're doing. So we're studying the urban heat island using surface temperature, air temperature, and clouds. So, and this is what we're doing. So looking at air temperature, surface temperature, and clouds. We do focus on October, December, and March, but you know, as you're doing your phenological garden or phenology campaign, green up in the spring bud burst, you can do urban heat island as well. And of course, the observations are all good. One of the changes now is you can use the app on your phone and your students can as well. And that is working. So I'll talk about that in a minute, how that can help. Surface temperature. Why do we study surface temperature and use infrared thermometers? Well, the reason we do that is surface temperature is at the heart of the energy budget. The sun is the source of energy. It warms the surface, trees, grass, buildings, pavement. And then if there's water, there's evapotranspiration. Some of the energy goes into that. Some goes into sensible heat flux. Sensible heat is the heat we feel. And then some of the energy is radiated to space, and that cools the earth. Now, greenhouse gases intercept this energy that's radiating to space and, you know, warming the earth up. But infrared thermometers also measure that temperature of that energy. So that's why surface temperature is such a good observation. Okay, so now here's talking about the app a little bit. You may have noticed the Globe Observer app now has atmosphere data entry at the top. You can click on that. You know, it's added to the clouds, mosquito habitat mapper, or land cover, and tree height. Then you click on new observations. Next, you could click on atmosphere, but there's also Earth as a system bundles. And the urban protocol bundle is basically the urban heat island bundle. So surface temperature, air temperature, clouds. Now there's relative humidity and precipitation, but you don't necessarily have to do those. Now, once you get into that, if the sites that you've already used that are near where you are with your phone will come up, and you can choose one of those sites if that's where you are, or you can create a new site using the latitude and longitude from the phone. So that's pretty neat. So I think that's a great feature. I see, obviously I did this at my house. I have Dr. C's house, my frost tube, my driveway, my carbon site, so all those things. But maybe I was picking my garden. I would do then a new site, and latitude and longitude would come up from my phone. And then I click on surface temperature and air temperature. So for your students, what you want to do is create student accounts in the Globe website, and then give them that login, and they can use that on their phone. And then they could take observations at their own house, in fact. And I've done this. So I have students, they sign out the infrared thermometer and the regular handheld thermometer, go to their house, take the observations. So then you can have, well, if you happen to have more than one infrared thermometer, regular thermometer, you can have students go to different places around the school and take observations that way. So here's how I want you to take observations. Put your arm out, point the instrument at the ground. Of course, this wasn't today. This was last summer when I did this. And then let go of the button, and then you look at the value, and you can enter that on your phone. You can write it down and enter it on the Globe website later. Let's see if I can do this. I had a video, students taking observations. Let's see if it works. I didn't share the sound. I work in it. So this was before the pandemic. Now this school, they had a bunch of infrared thermometers. So the older student, Olivia, she was helping the other students, and she just had them fan out, taking observation of this grassy field and entering their data. One of the things they made a mistake is the kids were reporting in Fahrenheit. And of course, we're not doing Fahrenheit, right? We use Celsius in Globe. In Europe, that's not as big of a concern, but many of these infrared thermometers, there's a little button to switch from Fahrenheit to Celsius. Now this school is pretty neat, as they have greenhouses, they have animals. So they actually, it's almost like a farm in the city kind of school. So these are all city kids that go to the school. All right, let's stop that. All right, some of the things I don't want you to do. Now, this is in the e-training modules on Globe. This is my youngest son, Timmy, before he grew about a foot. And now he's over 6 foot tall. I'm not sure how tall that is in centimeters, but maybe 1.8 meters or something like that. So you don't want to take the temperature of your shadow. You don't want to take the temperature of your feet. And then when taking the temperature, we want you to do it of one homogeneous area, and that would be one site. So in this case, it would be grass in between this ball field, and this is a playground here. And so we want 9 observations if you can, because that gives a really good average of that site. And if you notice, when you're out there and the students are out taking measurements, the temperature will vary a lot. You hit a nice grassy area, lower temperature, you hit a bare area, it might be a higher temperature. So that's why we have you do an average. We don't want you, and the students often do this, they take some temperature observations of this ball field and then others of the grass, and they mix them together in one site. We don't want that. And then the air temperature, you want to shadow the thermometer with your body. You don't want the students holding on to the thermometer with their hands so that it warms up the thermometer. This is the current air temperature. And you have to wait till the instrument doesn't fluctuate anymore. Now I want to talk about trees and something you can do with trees. Of course, you can use the app on your phone with the Globe Observer app and do the tree height. But I want to introduce you to iTree. Now this is, I had done this in the city of Toledo, and we mapped the trees, or 20% tree cover in the city of Toledo. So I'm going to try something new. Who knows if it'll work, but real time. And if things aren't going well, yell. Like, okay, that'd be great, and Dana. So this is iTree, the iTree website's itreetools.org. And there's actually several different things you can choose. In iTree design, you can actually figure out where in your yard is best to plant the tree, or where, to shade the buildings. And it'll give you some like metrics of how that is good. So I'm going to use iTree Canopy and get started. So here's instructions. Okay, it is international, and that is why it's so cool, because you can do it too. I'm going to go to Croatia. As notice this Karlovac that's taking the surface temperature observation at the school there. Okay, something like that. And then, okay, so they have US boundaries, UK boundaries. They don't have European boundaries, right? But you can draw a boundary. So you click on draw boundary. So you go, and I'm going to pick this urban area around the school. Let's see, click. So I'm making a polygon. So this is GIS, right? You can teach your students about GIS. Click, and see if I can finish it. Click. Uh-oh. Click.
New business in Malta could be the high prices because we rely on import.
Oh no.
But definitely the Green Deal will deal with.
Okay, got it. Okay, so sometimes it's hard to get the boundary to complete. I got it. Then you click on next. All right, and these are the different cover types that you can choose from. Or you can just do tree or non-tree. Or if you want to add a cover type, you hit plus sign. But we're just going to keep it the way it is. Hit next. And it'll calculate the benefits, US, UK, or Sweden. I'll just use US dollars. And it tells you the benefits of trees and carbon monoxide removal, nitrogen removal, ozone removal, particulate matter. Click on next. And here's our area. So we click on the plus sign. It gives me a dot. And then you have to figure out, well, what is that? What is that? Kind of looks like the roof of a building. So I'm going to click on buildings. So switch it to building, impervious buildings, save and create new. So it's going to do the next point. All right, that looks like it's on the road, impervious road. Save and create next. Looks like a sidewalk. Impervious road again. Save and next. See, this is a little dark. This is one of the challenges. I'm not sure what that is. I'm going to put a bare ground. Be nice to have a tree. Here's a bare ground. There's not a lot of trees in this area of Croatia. There's a parking lot, impervious other. Oh, see, we still haven't gotten a tree. All right, well, I'm going to quit there. But you see, it starts doing the percent cover. And if you do maybe 100 points, which might take you 15 minutes, it'll give you a pretty good estimate of the land cover, how many trees, what percentage tree are in your area, and then you can click on report. Okay, so let me get out of that. That's iTree. So I found that pretty useful for my students. Something else to mention is the urban heat island story map that NASA has created. And so here's the link to that. It's part of my NASA data, and that's really useful. And I do want to mention that we have for the urban heat island, a web page for students. It has videos on how to take observations and how to do projects. All right, so here I was talking about the World Cup earlier, and the US actually made the World Cup, the grouping, so that's great. There's my youngest son. This is normal for him, knocking people down on the football field. But the reason I bring up football is when we do science, and I think everyone on this call probably understands this too. In the US, it's maybe not as much, but you want the kids to do science, to learn science by doing science. And oftentimes, in the US at least, teachers have the kids read about science. So they have the kids take some measurements, but it's not real science. And so in soccer or football, you know, I've coached since Timmy was 5, and you know, every practice, the kids want to play a game, a scrimmage. They don't want to practice. They don't want to kick the ball at each other or work on foot skills. They just want to play. So that's the same way, you know, learn by playing or learn by doing science. And so one of the things we try to have students do is present their research projects. And of course, that's the IVSS, International Virtual Science Symposium, have the students create a project and present it. The reason we do that, now having in person, I think is much better if you can, and have your students make a poster. Here's the American Geophysical Union meeting that I go to each year, and the scientists present as posters at the meeting. And you see there's thousands and thousands of posters. This is how scientists share their research. Now, there are resources on the GLOBE website for helping students to create their projects. So just a few examples. Here's some students that looked at the temperature of their playground, and did their slide go faster if it was warmer or colder? This is kind of an old project, but in the Dominican Republic, their playground was asphalt, and they looked to see what color paint should they paint their playground to make it cooler. It turned out green. The student looked at water bodies. How do urban areas affect water bodies? And she measured the temperature of a couple of rivers in different places and found that the urban rivers were warmer than the rural rivers. Another thing we are focusing on this year is looking at sports fields. You know, American football or international football, you know, we call soccer here. And actually, this is with Vasco Montas from Portugal. We've been working with him on this. We're finding that the artificial turf is much warmer than grass, and detrimental to the kids. So I looked through all the projects. There are very few that look at tree cover and temperature in urban heat island. I found one this year, Crestwood High School in Michigan. They did do one, and they even used this Terra rover that was developed by the Aaron Project. And if you want to know more about that, let me know. And the Terra rover has an infrared thermometer on it, and you can drive it around, and the kids can map the temperature of different surfaces that way. So, you know, what are we looking for? Here's something students can do. Take surface temperature and air temperature using the Globe Observer app as part of the Urban Heat Island intensive observation period, or just in general. Take tree heights, and then compare the temperatures in the sun and in the shade. You can also map the trees through land cover on the Globe Observer app, or you can use the iTree. I want to show you the observations the last 5 years of surface temperature around the globe. And Europe has been participating. Croatia has been the biggest participator. Greece has been getting involved. Of course, Malta. My wife's family's from Malta, so it's you know, one of the countries that I'm very passionate about. And then the students, of course, can map their temperatures versus the satellite versus MODIS for a given day. And I want to share something with you that I didn't realize how easy it was. And that's Google Earth Engine. You can look at temperatures on that. And you do have to sign up with Google Earth Engine and say that you're an educator. And students can do this. I'm going to show you how easy it is. I'm going to go to a Google search, put in Google Earth Engine and MODIS. So MODIS is the satellite sensor that takes temperature and other things. So we click on the first one, MODIS collections for Earth Engine. There's all these collections. So BRDF is kind of hard to understand. It's the bidirectional reflections distribution function, but we'll skip that one. Albedo, which you probably recognize that, the reflectivity of the ground. Here's a reflection one. Here's a snow one if you're interested in snow cover. Here's the land surface temperature one we'll look at in a minute. Ocean reflectivity, fires. You can look at active fires. Okay, so lots of different data sets. Oh, leaf area index. Okay, so a lot of different data sets. Let's go to surface temperature. Click on the link. And then this one, there's a newer one, but I'll just click on this one. If you click on this box with the arrow, Google Earth Engine opens up. Now, this is assuming you have register logged in. You do have to click on run. And boom, there's our MODIS imagery for the Earth. Now the dates are here, so I can change these dates. I'm going to change it to last summer. Look at the urban heat on. I'm going to do July 1st, 2021 to September 1st, 2021. Hit run again. All right, so here's our temperatures from last summer. Let's zoom in on Croatia, Zagreb, and you can see the urban heat island for Zagreb. Yellow is warmer, cooler in the rural areas. Now, I've looked around Europe, and actually the urban heat island is not that bad in Europe. See a couple cities showing up. Does help if you know your geography. But if we go over to the United States, which is I find interesting, let's look at Florida for starts. And you see a lot more red versus yellow and green. So here's Miami along the coast, Tampa, Orlando, where Disney World is. Let's see here. New Orleans is showing up. All right, we have Savannah, Georgia. And if we go up the coastline, Washington, D.C., Baltimore, Philadelphia's up here. Look at that. That's a big urban heat on for Philadelphia. New York City, and even into Boston, Providence, Rhode Island. So all these cities have big urban heat islands in the United States. Wow, right? I was surprised. Even if you go over here to the Great Lakes, you can see Lake Ontario here. Toronto's showing up big in Canada, Buffalo still, Detroit. And before we came on, we were talking about why is this? Why is the urban heat island seem so much bigger in the United States than Europe? All right, so my other resources, I did already mention the story map. We do have a Google Classroom that can step you through some resources on urban heat island. If you want to join us on that, email me. And there's also a NASA badge that we created for urban heat island. So there's a badging system for NASA, and that's kind of a fun thing. So as a teacher, you can get a badge. And I want to end with our contact information. Janet helps me out on all these things. We have our Globe website for Globe Mission Earth, and then we have your Facebook page. So anyway, I'll stop there. Oh, and Lincoln put iTrees tool in the chat box. Thank you.
So thank you very much, Kevin. Thank you for all this information. It was very interesting, and also the tools. I'm really looking forward to try to dive into them and and try them. And there's a time for question, and I can already see Thanos with a raised hand. So please, Thanos, go ahead.
Hello, Mr. Kevin and everyone. I'm Thanos Theodorokopoulos from Greece Globe Virtual School and the Tiny Corral team. I have two questions for you. Is there any online app or some kind of program like Theogene to upload and visualize our data into a color map so we can investigate the urban heat island effect locally? And the second question is, are the surface temperature observations valuable under thick forest that the sunlight doesn't reach the ground easy, or maybe the satellites can't measure? Thank you.
Yeah, for the first question, to visualize your own data, I would use ArcGIS Online if you can. In the United States, every school has access to ArcGIS Online for free. And the Globe data, you know, if you do have to go to Globe, either visualization system or the ADAT system. You can use the API. Personally, I don't understand API. My students do, but that's good. But you can get the data that way as an Excel file and then upload it into ArcGIS, and it recognizes the latitude and longitude very easily. Now, that would take me to do a demonstration probably about 10 minutes versus I was shocked at how fast I could do that. Google Earth Engine and the iTree demonstrations were very fast. And then the other was under thick forest. There probably are a few observations in the Globe database under thick forest, but not very many at all. And that is an interesting research question: is how is the temperature different in the forest, you know, versus outside the forest, and where the satellite cannot observe, because the satellite's observing the top of the trees. I had done a study in 1990 in Atlanta, and we were in a forest and we put up a tower, and the temperature at the top, the top leaves got very, very warm, but you know, the temperature at the bottom did not change hardly at all throughout the day. So yeah, that's a great question, great research question to be able to look at.
I don't see any other questions at the moment, so but don't worry, write us into the chat. I can see some nice words about how nice the presentation was, so you can also add some further comments. And in the meantime, I would like to ask also, so you mentioned that in the United States we can see the cities more, the urban heat island. Is there any trend or any way that you would be using trees to lower it, like planting more trees in the cities? Does this happen?
Well, that's one of the big pushes in the United States right now, and I suspect across the world, is to plant trees. And in Toledo, I mean, this is something very, very new for us. So my students mapped the trees in Toledo this spring, and we presented that to the city of Toledo people. They're planning to plant trees this summer, but they're probably not planning to plant enough. They need to plant more. One of the challenges we had in the United States, we had a bug, the emerald ash borer. It was an invasive species, came from Asia, and it has killed all the ash trees, like all of them. And that was about 20% of our canopy in the United States. So in the last 5 years, many cities have lost about 20% of their tree canopy. So that means they need to replant all those trees, but the cities are maybe slow on that.
Mm-hmm. Thank you very much. Any further questions? But actually, I will have one more if no one else is asking. I was wondering about the i3 app. So you said you use it with your students, if I understand correctly. Could you just mention some example of the project, how you use it, or what would you recommend to use it in teaching?
Mm-hmm. Well, you know, it is a nice, easy activity for the students to do. And that was the beginning of our tree mapping in Toledo, was to figure out what percent tree cover there is in the city. And so they did the eye tree first before they used other sources of remote sensing to map the trees. But then they did things like comparing neighborhoods. So they drew the box around a small neighborhood and then another neighborhood that were different to see how the tree cover in one neighborhood compared to the next. And like I said, it doesn't take very long at all to do that. You draw your box, it starts having the points come up, you know, tree, grass, roadway, that type of thing. So they can compare the percentages and then the temperature. Now, one of the things I was able to do is to purchase infrared thermometers for all my students, and they went to their houses. And this is something that came out of the pandemic. I've seen some people do this with their students, is have their students use the Globe Observer app at home, and because they couldn't come into school, right? Engaging the students at home. So now that the surface temperature and air temperature can be used on your phone, it's facilitating students to do it at their houses or maybe a park near their house. So then they can, anyway, so the students did do the eye tree and then use the temperature. And I didn't bring up an example of that, I'm sorry. You have to figure out where that is. But it can be done.
Thank you. Well, so any further questions? Seems not. I think Kevin will stay with us now. So if any questions come up to your mind, you can still write or let us know later on. And if not for now, I would like to show you a little activity that we are preparing for you. I will share my screen. And it's we will not read it, don't worry about it. It's just to give you a quick glimpse. It's the activity is called Air Conditioned by Trees, and it's about finding out how trees actually cool our cities, how they provide us shade and cool places. So the aim of the activity is to compare the temperature, measure the temperature, compare the temperature underneath a tree and underneath an umbrella. So if you do this, you should, on a warm sunny day, you should be able to find out that the trees, the shade under the tree is actually cooler, or the air under the tree is actually cooler than the tree under the umbrella. And there are different reasons for it. One of the reasons is that the trees are actually catching the radiation, the sunlight, so they just shade the ground, but they also evaporate water, which also helps to moisture and cool the air. And therefore, if you do such comparison, you should be able to find out that the air under the tree will be cooler. And yeah, all this is, it was just to let you know what we are preparing. All this will be described in this one page. We will just do some few final edits, and it will just guide you through some preparation, where to find a locality, where to measure. It can of course be the tree that you are observing in the Phenology campaign, or any other tree that you find suitable. About thinking in advance with students what they think about it, what will be their hypothesis or their presumptions, and about comparing the results. And of course, we will be happy if you try the activity, if you will share it with us in the Phenology campaign, or through the discussion forum, or through an email. And of course, we would be happy if you share it also with your community. So if you do the measurements in this activity, we invite you to let know to your schoolmates, to other teachers in your schools. So yeah, this is a quick invitation. Here you will receive this one page and one page of a worksheet, which is like prepared for you so that students can see what are the differences and what are the similarities about the shade and the cooling by umbrella and by a tree. I will stop sharing the screen now, and we will send you the activity shortly after this webinar together with a recording. And also it will be available on the Globe website. So now the sunny and warm months are coming, and it will be just perfect time. You can combine these measurements with your phenology observations. So yeah, this was a quick invitation and introduction of a new phenology campaign and temperature measurement activity. And now we have one more thing for you, and it is the promised example from school. So I will play you a video that was created by Gozo College Middle School from Malta. And let me share the screen. Yeah, I should also share the sound. And in the video, you will see how students in Malta measure the temperature and what all they discovered and what were the next steps. So I hope you enjoy.
My name is Lily Hancock. I attend Gozo College Middle School, and through the global program, we investigated about the effects of trees on urban temperatures. So we carried out a few experiments during our science lesson about carbon dioxide and how it makes the atmosphere more hot, and that trees can reduce it. And now it was time to collect data. We chose two different sites, one with concrete floors and the other with vegetated grass with trees planted nearby. We used an infrared thermometer to take these measurements. Several times to collect enough data. When we analyzed the data, we found a difference of 9 degrees between the concrete and the grass area. Therefore, we can say that trees do have an effect of lowering temperatures on urban areas. We wanted to reach out to people and tell them what's happening. So we organized a climate action fun walk. And then at the fun walk, we handed out seed packs made from recycled materials and the seeds of local Maltese trees.
Okay, so I hope you enjoyed this video. And to me, I think it is a great one. It was a great project that combines many important things. The students, they did really like deep, thorough research. They measured the temperature, and they didn't stop with that. They actually did much more. They decided to inform the people in their locality. They decided to do some steps to change. As they found out that trees are helping to cool their environment. They made these seed bombs and distributed them to people so that people could plant more trees. I think this is pretty awesome. And I would like to use it as an invitation for you so that you can also try to change your cities. You can also plant trees like the students from Malta. And we have Ramona Mercia with us, one of the authors, the teacher and country coordinator from Malta. So Ramona, if you would like to add something about this project.
Hello, everyone. Yes, thank you, Lenka. It was nice that you showcased our example as a case study. It was very interesting for the students, and they were very surprised when they discovered the difference that trees can make. And that's why they wanted to go a step further and inform the community about the importance of trees. And not only by planting more trees, but also by trying to use cars less, because we know about the emissions. They also add to increase in urban temperatures. And I would like also to add that this year, we also did an investigation on surface temperature, and we did not stop with just involving one school, but we collaborated with other schools, and the students actually compared how different areas from across the Maltese Islands experience differences in temperatures, because the land use close to the school will definitely affect the surface temperature. It was really interesting for the students, even for us adults, to learn about these differences. And through the GLOW program, we managed to find all these differences. I don't know if there are any questions.
Seems not at the moment. Thank you very much, Ramona. Thank you for telling us a bit more and also sharing information about the project that's going on now. And I would like to follow up on what you said. I would like to invite all of you to share with us if you do the temperature measurements, if you discover something interesting about the trees and temperature and the surface cover around your school. We will be very happy to know about it. And of course, if you organize some activity, that's very interesting too. And yeah, I think we are coming to the end of today's webinar. So let's have some more space for questions, if there are any, or any comments, perhaps any first ideas to be shared. Okay. Seems not. Well, then we will be looking forward to hearing from you online, either on the discussion forum of the Phenology campaign, or we will be in touch by email. And we will also meet again on May 4th at another campaign webinar, another meeting with scientists, this time with Dr. Elena Bautista-Sparrow, who is actually very important person in GLOBE Phenology, because she's one of the founders of Phenology in GLOBE. So we will have the opportunity to meet her and learn about her experience. This is my final invitation to close the webinar. So May 4 will be the next one. And a recording of this webinar will be available on the Phenology campaign website as usually. And that's it for today. I'm very happy that you found time to be here. Thank you for joining and for being so active in the Phenology campaign. And I wish you a great spring days.